Hello, our today's topic is Google BigQuery, an introduction to Google BigQuery. Actually, it is a attempt to give the introductory concept and the very fundamental on the working of BigQuery in Google Cloud Platform. Actually, what is a BigQuery? BigQuery, as we know, is the application of queries through SQL, structured query language, on big volume of data warehouse. BigQuery is a fully managed enterprise data warehouse that helps one to manage and analyze the data with built-in features like machine learning, geospatial analysis, business intelligence, and so on. BigQuery's serverless architecture let one use SQL queries to answer the organization's biggest questions with zero infrastructure management. It is actually entirely designed to run on the cloud. So the big data warehouse, the large volume of data sets, those exist on the clouds, can be worked with the Google BigQuery, the application of SQL in the Google Cloud. So actually it minimizes the flexibility by separating the compute engine that analyzes the data from the storage choices. Okay. Now it separates. It makes the storage separately being dealt from the computing engine where the query is actually applied through SQL. So some example as a very fundamental and introductory session. Let's show some practical examples by how actually it runs on the Google Cloud. It can access the datasets from the user's own machine. It can access the data from the Google Cloud. It can access from the data sets from the external sources, external clouds also. From anywhere it can access the data sets, the bigger data warehouses. And the SQL can be applied on those data warehouses without any interruption. Or there is no infrastructural cost or infrastructural other factors are required. Now, let's have some practical example by how actually it works. Practical examples on how actually this Google BigQuery works. Now let's share the screen. I think the screen is shared. Now, firstly, as very introductory session, I can show you in the data sets. First, we know the data sets on which the query is going to be applied, on which the Google BigQuery is going to be applied. The data sets are here. You can see demo 1 and demo 2. Those are Excel CSV data sets, Excel CSV file, normal. That is not any database files that we are familiar with, like in SQL Server, Oracle, or Access, or something like that. It is just simple and Access CSV file. Those are kept as data sets. Okay. Now that is kept in the computer hard disk. Like the path you can see in my own computer hard disk as an example, I've stored these data sets in C users desktop data sets. Under the desktop, we have just stored here. In the normal hard disk, we have stored these data sets. Now what happens? We have to apply these queries on those data sets. So how to do it? Just very introductory and fundamental. As a very introductory and fundamental session, I will just show you how to apply SQL on those data sets and how they can be extracted from any sources, from your machine or from external sources, from Google Cloud, from any other external cloud. Those data sets can be extracted. First of all, in this demo version, this is a very demo version. So here directly will take you to the Google Cloud platform, SQL workspace. is a demo version only. The SQL workspace, we can directly go to the link console. You can see in the URL console.cloud.google.com/BigQuery. In this particular URL, you can find this particular Google platform where you can apply, where you can see the SQL workspace under which you can apply the SQL by extracting the data sets, by adding the data sets. How to do it? First of all, you just create the data sets. You just create data set, or you can create your data set under it, or you can open the data set and create the table under this, or you can create the data set itself. Okay, you can create the data set itself. So now we can open these already. Now open the data sets we have. Now these are creating data sets. We can create the new data set from it. Okay, we're opening this organic storm, so and so. Okay, under this instance, you can create the data sets. So let's create the data set. Like, for example, to create the data set, you just have to dataset ID, let it be demo 123. You can see the file location. No need to give the file location right now. Now I just create the dataset. Go to dataset. Then you can see in the screen, dataset 123 is created, and you have to go to the dataset. Okay, you can go to the dataset. Now again, I can show you. Again, you see demo 1234, another dataset you can create. Just show you creating the dataset. The dataset created. Now go to dataset. Now moving to dataset. Okay, demo 1234. Here demo. There are various datasets are created for instances. These are the demo. Now under this dataset, you can create the table. How to create the table? Under the dataset. Instead of database, it is said as dataset. See demo 123, demo 1234. Two datasets we have created. Under demo 1234, likewise in demo 123 also, you can get the same thing under demo 123. This is demo 123. Okay, this is nothing but demo 1234, and all same thing you can do by demo 123. You can open demo 123, and you are under demo 123 now. Under any of the data sets, you can create the tables. A particular project can contain a number of data sets. A number of data sets. On any data set, you can create a table from here. Either you can create afresh or you can upload. So see, already we have created in our hard disk, or you can find in the Google Cloud also, or other external sources also. So create table from, you can say upload. Just see upload. Select file. You can select the file by browsing from the desktop. We have saved the folder like it's directly you can have the demo 1, demo 1, demo 2. We have in the desktop demo 1. Now, by the way, you can see what is there in the demo 1. In the table, you can see what is there in the demo 1. There are 3 fields. There are 3 attributes we have. There are 3 fields: name, date, submission. Suppose submission, amount, some sort of fees submission. Just an example we have created. A very small example of only 7 rows, 6 rows. There can be a crores and crores of rows in the big data sets. Only 6 rows for your instances. So a data set is created in a CSV file, Excel. So there are 3 fields: name, date, and submission. We have these. And now what we have to do, we have to just CSV format demo 1. We have selected that particular thing from the desktop. We have selected that particular thing from desktop, or the folder we have created inside the desktop, that is data sets, the folder we have created in the desktop, which you can find from the desktop data sets, under which also you can get the same thing demo 1. So you select from it. Now table name definitely is demo 1, or any table, any name you can give. The table name is demo 1 for your understanding. Auto detect the schema. Schema means the attributes and their properties. The structure of the table is the schema. Structure containing the attributes and its properties is called the schema. So you create the table. Table is being created. So now the table created, go to table. As you go to table, you can find these three things. Name, date, submission, as you can see. It appears on the table schema, name, date, submission. It's appeared. You can edit the schema's properties and all, no need right now. So this is schema, we can see. Now what we can do, we can run the query, SQL query. In new tab, in a split tab. Split tab means this tab is splitted. Here you can apply the SQL query. See here, the output will come. Select star from. This is the way. Select star from the table. Now this is the way is select star from organic storm dot demo 123 is the data set name. Organic storm 334007. It is actual instance under which actual SQL, the particular portion of the application is created for creating the, this is actually there, which has been created for holding the data sets. Number of, it can hold innumerable number of data sets. So under organic storm so and so we have created already the demo 123 data set under which the table is demo 1. So it's a hierarchical location is shown here for demo 1, hierarchical existence of demo 1. Under organic storm 334007, there is a demo 123 data set under which demo 1 is the table. We have created the demo, we have extracted the demo 1 table from our hard disk. This is running in the Google Cloud. This is not running in your machine. console.cloud.google.com. This is running on the Google Cloud. Limit 1000 means maximum 1000 number of rows can appear as result. As result, maximum 1000 number of rows or tuples can appear as result. So just run it, nothing else, just run. Query results. Here the result you can see. Here the query result you can see. Just see the result. Whatever is stored in the hard disk, that file, the same result comes here. Okay, absolutely, the same result comes here. Now this is simplest SQL what we have applied. Simplest SQL. Now let's group. Let's run an aggregation query with aggregation function. Select name, comma, sum of submission, sum submission from so and so. From so and so. Group by. You have to use the group by clause, because whenever you are running the aggregation function, you are adding the submissions, all the submissions according to the group by your name. Means against any particular name, the grouping will be done under any unique name, under any distinct name, under any distinct name of the data set table, under any distinct name, the total submissions will be added and the sum of on the total submissions will be done, and the name, distinct name followed by the total submission, that sum of all the submissions will appear. So we have group by name. Same, limit 1000 means 1000 records will be shown. Run. Here the quotation is missed. Query results you can find. You can find here the query result. You can find the result here. ABC 14,000, BCD, DEF. These three are the distinct names in our data set. Just have a review on it. These three are it's running properly or not. Just see ABC, DEF, ABC, BCD, DEF. ABC, BCD, DEF. ABC, the sum 5,000 plus 9,000, that is 14,000. It comes under ABC 14,000, as you can see as a result. ABC 14,000. BCD total is 9,000. DEF total is 9,000. XYZ is a single one, that is 7,000. You can find here. ABC, the total will be computed against the name ABC. Keeping ABC fixed, if this query calculates the total 5,000 plus 9,000, 14,000. DEF also it calculates the total like 2,000 plus 7,000, that is 9,000. Okay, so DEF 9,000, and only distinct names will come. Names will not repeat. No duplication of names will come because it is grouped by name. So the name is a parameter which is used for group by clause, used by the group by clause. Grouping by name means keeping the distinct name and summing the submission against that particular distinct name. That is being done here. So we can see this query is running. Now we can name sum of submission from so and so. Okay. Now we can rename also as total. So the attribute is renamed here. So just look at it. The attribute is renamed here as a query result. Yes, as total. Just look at here, name and total. Total means the sum of submission is a derived attribute. Sum is an attribute, is a function of the attribute. Sum function of this attribute is renamed as total. The sum of attributes is renamed as total. So total is given here. Total is given here. Total appeared here as the attribute name. It's a derived name of the attribute. So I think you can understand this one, that how the SQL is being applied on simple data source. And if you can apply the SQL, if you want to apply the SQL from, suppose we are going to this data set demo 123, we go into open the demo 123. This one, open. Demo 123. Now we can create a table, or we can afresh, we can start create a data sets, like open these afresh. Create data set, create data set, ID. You can say demo 5. If you can give the name of the demo 5, creating that, go to data set. Yes, then you can create a table. Now what happens? You can choose any of the options here. Google Cloud Storage. I have chosen the upload option. This option is applicable for uploading the particular data set from our own machine's hard disk, user's own machine's hard disk. And this drive that will upload from Google Drive, Google Cloud Big Table, Amazon, this Amazon Cloud, this will store from the Amazon Cloud. Now we can store any table from Google's Cloud Storage. Now there is a select file from GCD basket, GCS basket, browse. Now you are now searching from Google's Cloud, no basket found. Okay. So you can choose anything, file format, Avro. There are other formats that they are also available. CSV, You can choose the CSV format also. Select file from this basket. From here, you can specify that where to choose the basket and what is the examples and all. So you can choose in this way from the Google Cloud Storage. Now here you can also choose the drive from Google Drive. Whatever data is available from the Google Drive. Okay, drive URL. You have to select the drive URL. Okay. Now here also you can find the apart from Drive, the Google Cloud Big Table. From Amazon also you can find Amazon. Amazon, select path, or you can give the path also by typing. So in this way, from various sources you can extract the table from. From various sources you can extract the table from. Okay. Now in this case, when we create the dataset form, if you go for create dataset location, these location, from dataset also you can extract from some other sources, not only table. Table you can extract from other datasets, and full dataset also you can extract from other locations like this. If you choose the create dataset, you change the name, and under the organic storm project ID, this is a project ID. Under this project ID, you can choose from any location, US, multiple regions in United States. You can choose the data location. Okay. Table extension. So maximum table, how much? So you can select from US, multiple regions, the data sets. You can select the US East 4 data set. You can select the West 1 data set. So those are the big data sets already existing in the cloud. You can choose one of them, those data sets. And you can choose the tables from external sources also. From those data sets, you can select the tables also. So this is a way, not only using your own systems data, rather you can use the data from the other sources, the other clouds also, the Google Cloud also. So that is the bigger thing of this. Now here, what we can see is a group by clause is used. And as an example, we have run the group by clause. Okay. Now you can select another query. You can increase that query. Select start from. Select start from so and so. Select start from so and so. Where total greater than 10,000. Okay. But total greater than 10,000. Here see a sum of submission, sum submission. Is greater than 10,000. So here selecting from, select start from, select everything from, select all columns from, star means all columns from this relation, this result. This is a view. This will work as a view. This will work as a view here. This is a result that is derived. Select start from this result. What is appeared there? This is the aggregation result. The aggregation result which has appeared as a result now slightly before, we have seen the result appeared here. That result, we are selecting all the columns from that result, and we are imposing a condition where sum of submission, that one of the attribute, derived attribute now is sum submission is greater than 10,000. It was caps. Now see, sum of submission is no longer, it is renamed as total. That's why total is being accepted. Only ABC will be printed, ABC's details, because the total which is actually the sum of submission, derived attribute is total. The total is being used as attribute parameter here. The attribute parameter which is used in the query under the where clause, we have to use the total, because total is renamed. After renaming the total is the new attribute name, derived attribute name. So you have to use the total greater than 10,000. Okay, total means sum of submissions. Under each distinct name, the sum of submissions. So only for ABC, the total fees submitted is 14,000. So it is greater than 10,000. So the result will come like this. Okay, I think it's clear how to apply the SQLs and how to customize the query in slightly different form, how to change the queries slightly to apply here in the Google Cloud and other data sets, even your own computers, data sets from your own computer's hard disk, to get the result. So, and these queries will be can be applied on large volume of data, okay, that Google used to maintain. The larger data sets, the larger amount of data sets, the larger volume of data, the larger volume of data warehouses, which stores billions and billions of data relations and all schemas. So the details of the people, the different type of details of the people, the different type of details of the other government and non-government informations and all. So whatsoever big the data sets are, the data warehouse is, these queries will always apply on those things to retrieve the result in shortest possible time frame. So thank you so much. So this is a very introductory lesson on the Google BigQuery. In the later videos, we'll explore vividly on how to apply this Google BigQuery on big data warehouses and on the bigger data sets. Thank you. Thanks a lot.